Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Chaiken, University of Albany, Joel Chaiken, his brother. We are here to go over and show you how to approach SAT math questions. This is from a non-calculator test. Okay. If A is 2, why don't you look at it, pause it, and then continue on. If A is 2, then what is the solution to the equation above? Oh, so we're going to want to substitute. At the minimum, we're going to substitute, right? So really, if A is 2, right? You at least have to do that, right?
Yeah.
Then you have to.
Well, my first reaction is that this is different. This is stated differently from the typical question, what is the solution to the equation above?
Okay.
They said solution set, and then 3 of the choices have a set
single. Yeah.
A singleton set, and one of the choices is a set of 2.
Right.
2 numbers.
Right.
So this leads to me to think that this is a question that tests the concept that certain equations can have more than one solution.
Right. Yeah.
Now, this is a so let's substitute a equals 2, and we see this is probably not a singular thing. So I would think, what I think is they're testing whether you know the concept that an equation might have 2 solutions, and then they give a single choice that indicates that this only a single choice, this one, that indicates a solution set with 2 solutions.
Right.
And so what I did at the beginning was check if answer A is the right answer. And so I checked it a couple x equals 3 and x equals 6 with the A replaced by 2, and bingo, they both work.
Wait a second. Stop it. How can x be 3? If x is 3, then this equals negative 1.
Stop it.
It's impossible.
No. Let's do it. The square root of 3 minus 2.
Yeah.
Does that equal
1?
3 minus 4. Now, 3 minus 4 is minus 1.
Yeah.
3 minus 2 is 1.
Yeah.
And the square root of 1. So the question is it valid to say that square root of 1 equals minus 1?
No.
And it is. It does.
No.
Because the square root of 1 is double valued.
Oh, my God.
It's double valued at minus 1 and plus 1.
No way do you not know that, Seth.
Well, it sure looks like...
Seth,
it sure looks like that's what they intend.
In math.
And I challenge you to look up the SAT's answer.
Okay, Seth.
And see whether it's A or D.
Seth, you have a PhD in math.
I do, yeah.
I can't. Now, I struggled with this a few years ago. I can't believe you don't. But yet again, I struggled with this a few years ago too, and I had to look it up. Wow, you don't realize that. When you see the square root sign, there's a definition to that, and it is the principal square root. It's always positive.
Okay.
Yeah, that is the definition of this symbol.
Oh.
That is the
Okay,
definition
good.
of the
So
symbol.
the question
Oh my
is that the
God.
rule that they applied?
It has to be. No, I think it's a universal rule in math.
No, it is not a universal rule in
Oh, are
math.
we going to have to Google this?
Don't Google it. See what
So,
they think, what they propose as the answer, and also check whether
okay.
at the beginning of the test they state explicitly that real
Oh
square
God.
roots are always positive.
Okay, this is going to
Yes
take.
or no?
Okay, this is going to take a little
And
time.
the truth is, the reality of math is that there are two square roots to every positive real number.
Yes.
One of them is
Yes.
positive and the other is
Yes.
negative.
Yes. Yes. Okay, people. We're gonna have to wait because I have to look this up. Which test was this? This was test 4. Okay. Test 4. Here we go. The answers. So let's. I'm not sure if this is the right test. So let's go back to question 8. Question 8 in the no calculator math was A. Question 5.
Wait,
Question 6 of the no calculator math was B. Okay, so here we go. Ready? This is we're gonna get the answer first in this problem because Seth, yes, the definition of that
I
symbol.
know. I heard what you said. The
Okay.
claim is that your claim is that on the SAT
Yeah.
they declare to the students a certain definition for that funny symbol, and on the SAT that square root symbol is defined to be meaningful only on 0 or positive numbers, and it is defined to be the positive square root.
Okay, this is what they say. Look, these are the instructions. See them? No, where do they say that the symbol is a positive square root? Because that's just standard. Maybe.
Wait, let's see. Let me see it again.
Yeah.
I'm a little skeptical.
Okay, and there's no complex number here.
Wait. Hold on.
Okay.
Where does it say about the square root?
It doesn't, because this is defined as the symbol.
Where is it defined? Where is the square root symbol defined
Somewhere
in the
textbook.
SAT?
Okay, not on the SAT, but in
Okay.
every math textbook it is.
Okay.
Okay.
Now. If here's another remark. If you followed your nose,
Yeah.
and solved the equation the mechanical way, which is not very efficient, of squaring both sides,
Yeah.
you would get a quadratic equation whose solution set is the one I indicated.
Seth.
Try it, you'll find it's true.
Seth. Okay, you haven't taken 11th grade math in a while. It's been a while, right?
No, I remember 11th grade math, they did cover this.
Yes.
But please look up for the
Okay.
get the
Pinky
test. The test date.
I have the test data right in front of me. Ready for
Okay,
Pinky Bet?
look up what the
No,
SAT
we need Pinky
says.
Bet. We need Pinky Bet. Pinky Bet, I'm right. Okay, even if you don't agree, we'll do Pinky Bet. 9. The answer is D. Of course it is.
What?
Seth, the answer is D because you forgot 11th grade math because you're so PhD math stuff. Look, it's great to get a PhD math. I'm not knocking it. But, yeah, that's the way that symbol is
So they
defined.
say the answer is D?
Of course it's D. Because you're forgetting something else that's taught 11th grade math called the extraneous solution. Have you ever heard of the extraneous solution?
Well, we talked about it.
Yeah, whenever you square both sides of an equation, sometimes you get an equation that doesn't, sometimes you get an answer that's extraneous that doesn't make sense. Every time you square both sides of an equation, which is ultimately what you really got to do here, all right, you may get what's called the extraneous solution, which means that the answer, you get an answer that doesn't work, okay?
Yeah.
You get an answer
that's because yeah, so if the left-hand side were positive and the right-hand side were negative with the same absolute value, Then when you square both sides, you get equality. Okay. So
Okay. So
thank you. I was wrong.
this is ultimately going to give an
So
extraneous
I think
solution.
it's wise for you students who may be taking the SAT after getting through some AP calculus. You need to worry about this.
Wait, what does AP calculus have to do with this?
Well, when people go further in math, they will be taught that square root is a multi-valued function.
Seth, could you? Well, okay, later, could you
Okay.
look that up and show me where this symbol has multiple answers?
Okay,
Now,
I'll try that. Yeah.
this does, Seth, because Seth, I struggled with this myself a few years ago because I was wondering. In fact, I even may have asked you about this a few years ago because I always ask Seth the questions I can't do. This has two solutions. When you write it this way, you can't argue. When you write the equation x squared is 25, there's no question that you have two
Oh,
answers
okay.
to it. So if you wrote x squared is equal to 1, of the answer,
Yeah.
this
Sure.
absolutely has a 1 and negative 1. But you write the square root
Uh,
of 1, you write the
okay.
square root of 1, it's
All
only
right.
equal to 1. Look it up.
Yeah.
Look it up. It has to be. Because otherwise this function says, look at it this way, look at it this way. This is not a function, but it is a function. Here, let me slam it down on you, okay? Here. Everybody talks about
All right.
square
All right. Let's okay, I'm looking up.
No.
I am looking it up on Wikipedia.
So also let's do it this way. Look, y is the
And
square root of x. This is a function. It's single valued. It has this crazy graph. Okay? When you write this, it is a function of x. Has to be a single value.
No. Okay. Well, what Wikipedia says is that the square root symbol is used to denote the principal square root function.
Yeah, right. Yeah.
Right. So, and the principal square root function is that function that Joel has described.
That's right. Absolutely.
And so, indeed, I guess I have to agree with you.
Yeah.
But so therefore, I'm warning listeners to watch out for this use of the radical symbol to denote the principal square root on the SAT.
All the time, not just on the SAT. Well,
it depends on what mathematicians do. Is if there is any possibility of ambiguity, they spell it out.
Fine. Look, if someone's going to be getting a PhD in math and getting the Nobel Prize in mathematics,
there's no such thing. There's no such thing as no. Alfred Nobel purposely omitted mathematics in the subjects that he created the Nobel Prize for.
The bottom line is there's plenty of time for people, if they go into advanced math, to deal with what you're dealing with, right? Right now, when you see that symbol for the next few years in your life in math, it is the positive square root. And then because you're given the square root function, this is a function. If it has two values, it's not a function anymore. So anyway, let's
certainly a square root.
So now let's do the problem the normal way, okay? So you
will see if when you read Wikipedia, and in general, it's a peculiar use of language. Every positive, non-zero real number actually has two square roots, but the radical symbol symbolizes, a genuine function.
That's right.
Of positive integers, of positive numbers, x, whose value is that square root of the number that happens to be positive.
Yes, exactly.
Okay, sorry about that. But I am a little disappointed that the SAT makes a question on this subtlety and picked that particular choice.
Well, the thing is, they're checking to make sure you can do extraneous solutions. Okay, Seth. So now let me do it the way you normally do with an 11th grade math. Now, this problem, by the way, this you can. Seth's right. Actually, you look at this thing, you are going to get a quadratic, which is disgusting. So it's you square both sides. So this is x minus 2 because you square the square root, it blows off the square root, and this is x minus 4 squared. Oh my God! Don't make a mistake I sometimes make. We all make where you write. I'm not even going to write the wrong thing because I don't want to reinforce it. But you have to FOIL this. It's x squared minus 8x plus 16.
Yeah.
Ouch. Ouch, ouch, ouch. This is a quadratic. So you're going to go 0 is equal to x squared. Ouch. Minus 9x plus 2 plus 18. Now, at this point, you may say, let me just guess
6 and 3.
Let me just have one point is you could just, at this point, you could say, I don't want to deal with this.
The solutions to that quadratic equation has solutions.
Okay,
6 and 3.
Fine.
6 times 3 is 18, and 6 plus 3 is 9.
That's not my point. My point is that at this point, you may say, I don't want to do this, and you can just use guess and check, and you can just try which answer works. Okay, that may be fast.
But it's here, it's critical. Here, to get the answer right, you have to know to reject.
Yeah, we already went through that.
The extraneous solution of 2.
I know, but yes, that's right. That's right. Okay, let's do it the traditional way. So you're going to factor this thing. You could use the quadratic formula, but to be there forever. So this is x and x. What two numbers multiply to 18, but add or subtract to 9? Seth's right, 6 and 3. The 9 is the negative sign, so it's negative 6 plus 3. So the answers are 6.
No, negative it's x minus 6 and
I have that.
X minus 3. You wrote a plus 3.
No, it's x. No, it's when you factor it out, it's x. Wait, x. Oh yeah. Oh, you're right. It's both. It's both. Yeah. You're right. Yeah. Sorry, Seth. Sorry. You're right. Yeah. When you factor, you're always supposed to check. And I was going a little bit too fast. When you factor, you always FOIL out to check. You're right. You're absolutely right.
Right.
Okay. Great. But I still would have gotten the right answer. Anyway.
Okay. So
Seth,
let's write a summary.
Seth, I'm not done.
Oh.
I'm not done. Please. Calm down. Calm down. Okay. So
I was all worked up. My energy. Okay. I have a lot of calories from yesterday's dinner.
Okay. Yeah, that was very nice. Okay. Now, I'll tell you when I'm done. Okay, great. So now we're solving this thing. This is a classic quadratic. You get two answers, 6 and 3. Now, this is the critical thing. Ready, everyone? Because you squared the equation, you cannot. Checking is sometimes optional. It is not optional. You must check both of these answers for what's known as an extraneous solution. You have that responsibility because you square both sides. Now, x, just check 6. So 6 goes in here. 6 minus 2 is 4. The square root of 4 is 2. 2. Okay, that works. 6 minus 4 is 2. That works. Now let's check this one. 3 minus 2 is 1. 1 squared is cool. That's 1. Equals, now what is this? 3 minus 4 is negative 1. That doesn't work. It's
a statement. 1 equals minus 1 is a false statement.
I know. This is an extraneous solution. So nobody likes extraneous solutions, but we have to deal with the reality. Zeitboard froze. We are going to cross it off with a red, and then we are done. This is a problem of an extraneous solution.
Okay, so circle the true answer.
The true answer is 6. You have to throw out the extraneous solution. Anytime you square both sides, you have an extraneous solution. And you want to see a cute reason why I love to show this. Here, let's do this. Look, x is 5. Seth, tough question. What is x? Well, how to solve that equation? What's the answer? Come on. It's not that hard. X is 5. What's the answer?
5.
5. Okay, right. We're going to square both sides. Right? Now we're going to solve this equation. X squared is 25. Ooh, x is plus or minus 5. Uh-oh. We square both sides. Look, we got 2 solutions. Now we go back, extraneous solution. X is 5. So does x is equal 5 satisfy that? Yes. X is negative 5. Does x equal negative 5 satisfy this? No. So that is the extraneous solution. Okay, so that's how you see very quickly when if you have an equation, you square both sides, you can get an extra answer. Oh, I don't think we're going to do Throwback Thursday today.
You sure?
Maybe I don't know. Yeah, this is tough. This is a lot. Today we did a lot of stuff. What do you think? You think we should do Throwback Thursday?
Yeah, why not?
Okay, we'll do Throwback Thursday. So Seth, I know you're dying to say something else. So what else?
No.
Okay, but it shows that Seth did not remember the definition of that symbol.
Yeah.
But now hopefully we've talked
remember,
about.
So the definition of that symbol is principal square root. Now it is spelled the same way as the principal of your high school.
Okay, right. Principal, right.
Pal,
right. So hopefully after watching this video, you will now be really aware and really understand that. Now, you may have already not even noticed it or even paid attention to it because it was taught, but it is important that there are two numbers that you can square to get one.
Yeah.
But that's not what that symbol is asking you to do.
Well, when you read Wikipedia, the Wikipedia authors wrote it in a careful way, and what we say is a positive real number, has two square roots. A square root of a number is a number which, when you square it, gives you that number. And then point 3, that crazy symbol is called the radical symbol.
Right.
And the radical symbol denotes a genuine function.
Right.
As Joel said, this thing that picks 2 square roots does not mean a function, because a function is something that for a given argument gives only one value.
That's right.
The radical symbol symbolizes a genuine function. That genuine function is called the principal square root, and it is defined to be, for positive numbers, that positive number whose square is the given number.
Right. Okay. Yeah, okay, good. Yeah. I'm just glad there are two of us, because sometimes I make big mistakes and sometimes you make big mistakes. So I'm glad there are two of us to catch each other. God forbid we both make mistakes, we don't catch each other. This is why when you get out of school and you build airplanes in teams, because everybody has to check themselves. When you get out of school, you always work together, because everybody has to catch each other's mistakes. It's a net of everybody working together as a team that really gets things done, as opposed to one person by themselves. Although when you're going for, like, I don't know, some math genius thing, very often, sometimes you work by yourself. Okay, so here's a question from Throwback Thursday. Yesterday was Thanksgiving. We decided we just wanted to eat instead of do Throwback Thursday. So here's Throwback Thursday question from a test from 20 years ago. It has this question here. You don't never see this type of question on the modern SAT, the post 216. It's a simple. This one you see is harder, but we'll do that one maybe next week.
Okay, so, which one are we doing?
This one.
Number 3.
In bloody red here. Sorry for the red. Okay. So, wait, let's make it nice. Okay, there we go. The figure above will be rotated 90 degrees about 0.8 in the direction indicated. Looks to me like counterclockwise. Which of the following represents the rotated figure? Okay. So, just don't really see this on the post 2016 SAT. You've done this. People I'm sure can do this. It's not that hard.
Yeah.
Right? I mean, it's A, right?
Yeah.
It's A. Yeah, there's not much to talk about this, right? You just have to have some sort of visual, spatial sense.
Yeah.
But you take this thing and you rotate it this way, so it starts to go this way, and then it starts to go this way, and then it ultimately ends up this way.
Yeah.
This way. Right?
All right.
Yeah. Not much to say, right?
Yeah.
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 Okay.
And of course, you have to know that 90 degrees is 1/4 of the way round the circle.
Oh, yeah.
In other words, a right angle.
I forgot about that. You have to know 90 degrees.
And they do tell you, you don't have to know that the convention in mathematics for measures of rotation is positive rotation is counterclockwise, because they tell you the direction indicated.
Right.
Right.
Yeah.
Another way to look at it, another way to see it is, here's the origin. We could label the points A and B. When you rotate point A 90 degrees, it goes to here. And then when you rotate B 90 degrees, goes to here.
Yeah,
so this figure gets transformed into this figure, where this point here is the transform of A, and this point here, which I use for prime notation, is the transform of B.
Right.
Yeah.
Right.
Oh, yeah, this is one of the easier throwback questions.
Yeah, this is one of the easier. But you don't normally see this in post-2016 SAT. You don't really do rotations and stuff.
Yeah. Notice it's like in the spirit of what they threw out. There are no numerical or algebraic calculations in this problem.
Interesting, right. Yeah.
It's a test of understanding a couple of things put together. Know what 90 degrees means, what measures of angles, what rotation means, and then basically some visualization skills.
Right. Yeah. Exactly. Yeah. So it feels.
Gosh, I think it'll be really tough. How would this question be communicated to a blind person?
I have no idea.
Yeah,
So
it's not fair.
Right. Yeah.
Yeah.
It has a whole different feel to it from the post-2016 questions.
Yeah.
Okay, so I guess that's it. I hope everyone got something out of today. Particularly now, you will never make the mistake Seth made about the symbol, and symbols are important in math.
Sorry about that.
So no, you're kidding. No, never apologize for anything. Mistakes like that. Yeah. It's okay. It's fine. No, it's good. It's good. Now we made a point of it. You learn more math when you make mistakes or you forget something. So, okay, everyone, have a great day. Please give us your comments, and please send us SAT math questions you'd like us to go over at SATmathquestion@gmail.com. Okay, everyone, take care. Bye.
Okay.